We continue learning the how dimension of the independent inventory management. In the last video, we have discussed how to apply the ABC analysis to identify the most important inventories. And this video, we start to discuss the EOQ and the matrix, the three common matrices we use to evaluate the inventory management. So we start for the matrix here and then we move to the EOQ. The first matrix I'd like to introduce is the inventory turnover. This is the most common matrix we use when we mention the inventory management. This is talks about how company use their inventories, and it equals to the annual cost of the goods sold divided by the average value of the inventories. If you are a financial student, you may be very familiar with the turnover stuff. So the inventory turnover, it measures how quickly and efficiently you turn inputs into sales. So let's take a look with the example here. A company's annual cost of goods sold is 12 million and it has an average inventory of 2,400,000. If the company operates 52 weeks each year, what is its inventory turnover? So according to the formula, we can obtain the inventory turnover is 5 turns. 5 turns is the result. What kinds of conclusion, what kinds of information we can obtain for the 5 turns? It means the company can use its inventory 5 times to generate the profits. So if we understand for that way, we will know the higher inventory turnover means the better application of the inventories. So this is we always want to have a higher inventory turnover, but it also depends on the industry. So for some industry like the grocery stores, it always have a higher the average turnover is higher than other industries like the airlines, like the retail, the department, discount retails, and others. So inventory turnover depends on the areas. So if you obtain a result about the inventories and you want to know how great you use the inventories to generate the profits, you need to compare with the benchmarking in the same industry or compare with your former turnover numbers. So you will have an idea whether you make some improvements, whether you did a great work or not. So this is about the inventory matrix. It talks about how quickly and efficiently you use your inventories. And the second matrix I'd like to introduce is the fill rates. So this is how quickly or what is your rate to fill the orders. And we have two types of the fill rates, the item and the line. So it depends on which one you choose. And considering these two scenario, the scenario A, we have 10 lines for each of this A and B, and you will have an idea about the orders. And for the A, we can say that it's fill the order the orders for line 1, and it also fill the 20 for the line 2, fill 30 for the line 3, just like fill the lines order for the first 9 lines. And for the B, it doesn't fill the line 1 and 2 and 4 and 5 and 7 and 8. It only fill the line 3, 6, and 9 and 10. So this is how Scenario B, fill the orders. So according to the information here, we can calculate both the item fill rate and the line fill rate for A and B respectively. So for the scenario A here, the total orders it filled is 180, which is sum all the orders, the units it fills. And the total orders actually is 400. So we use 180 divided by 400, we have 45. So the item fill rate is 45 for scenario A. And for the B, even though it just like fill 4 lines, but because the last line here is 220, it takes a large amount of the total orders. So the you feel like for the scenario B, the item fill rate is 310 divided by 400 is 69%. And for the line fill rate, we focus on how many lines you fill the orders. So for scenario A, it fills 9 lines here. So we use 9 divided by 10 is 90%. And for the B, it only fill 4 lines here, so we use 4 divided by 10 is 40%. According to the information, the result you obtain here, you will have an idea for the scenario A, even though it doesn't have a higher fill rate for the item, but it has a very high fill rate for the line. So for the line fill rate, it is acceptable. But for the scenario B, the 69% and 40% are not good numbers, so it doesn't have a very good fill rate for scenario B. So this is how we calculate the fill rates and what kinds of information we can obtain considering the inventory management. And the last one is what we call the days of inventory supply. So in general, when we want to know how much inventories you have, we have two ways to ask. It's like we ask the details amount of the inventories you have, but in general, another way we ask is about the time. So how many days of your inventories? How many days of the inventories you have? So we ask, considering the inventories you have currently, how many days you can meet the demand. So considering that dimensions, we use a matrix we call days of inventory to have an idea about your inventories. So take a look at the example. If you currently have 800 pairs of the headphones and the average demand is 240 per day, so you will have an idea like the current inventories you have can meet around 3 days demand. So this is another way we're considering how much inventories you have. So this is the most common three matrix we use to evaluate the inventories level and how great your inventories is. And the another thing I'd like to introduce for this video is about the EOQ. The EOQ is the tools to help you to decide how much inventory you should order. So this is about the quantity. For the inventory management, we have two core questions, the quantity and the time. So we analyze the quantity first. So we use the economic order quantity. In order to have a feeling about the right quantity of the inventories, we consider a very basic model here. So we make some assumptions and then we can have the idea about what is the best decision of the quantity you should order, which we call EOQ, the economic order quantity. So for EOQ we discuss here, we just start for a very simple, a basic way. So we make some assumptions about the situation we meet. And according all of the information here, we can know what is the correct quantity. So we start for a basic model here, a basic EOQ model. We state these following four assumptions to make things clear. So the first assumption we have for this basic EOQ model is we only look at one product and one market. And the actual demand, we have a clear idea about it, and the demand is constant. So it is always stable. If you need two per day, then every day you need 2 units. So this demand is constant. So you will have an idea about how many units you need in a specific time period. And the orders are received instantaneously. So the delivery lead time is 0 days. What does it mean? It means you place order right now and you will receive the orders right now. So this is like orders are received instantaneously. So let's take a look with figures. This picture, the vertical line here represents the inventory level and the horizontal line here represents the time. So when you make an order, you will receive the exactly order. So if you place an order here, you will receive the order immediately. And because of the demand is constant, so every time period, a specific time period, you need the exactly same units of this demand. So these lines represent the inventory level reduces with a straight line here. So this is what we have. And when you have a zero here, a zero cost, a zero inventory here, you place another order and you will receive the orders immediately, and it starts repeat the same patterns here. So we will have an idea at the beginning of one time period. You keep Q quantity if the Q equals to the order you placed. And at the end of the time period, you keep zero inventories. So during each time period, the average inventories you keep on hand is Q plus 0 divided by 2. So this is 0.5 Q. This is the average inventories you keep on hand for each period. So now let's translate our assumption into a simple mathematical model that we can use to find the optimal quantity for a given situation. So for a basic EOQ models, we considering the following notations. We use a big D represents the annual demand, and we use a small c to represent the unit value. So what is the values per unit? And we use a small I here represent the holding cost, and the big K here represents the order cost, and big Q here represents the order quantity. So remember all the notations here, and then move to transfer all assumptions into the mathematical models. So for the basic EOQ models, we considering two costs, the holding cost and the ordering cost. So this is the only two costs we focus on. We only have those two costs for the inventories we have, and we place an order. So for the holding cost, because we know that for each period, the average quantity of the inventory you keep on hand is half of Q. And because for each of them, the holding cost is H, which means if you want to keep per unit, you need to pay for the small h. If you have 20, then you have 20h as the total holding cost that you have for each period. So the total annual holding cost here, we use half of Q times small h. And now we move to the ordering cost. The ordering cost is related to how many orders you place. If we want to know the how many orders we place, we have two information here. The annual demand and the quantity. So if we know the annual demand, for example, if we know the annual demand is 200 units, and we know every time, this is the the order quantity you can place. Every time when you place an order, you can order 50 units. So during the whole year, during this period, how many orders you have? We just use 200. This is the demand you need, and each time you can order 50. So you need to place 4 orders here. This is the number of orders. So if we know the annual demand and we know the quantity for per order, and we will know the total number of the orders, and we use the number of the orders times the cost, the big K, the cost per order. This is the total ordering cost. And this red line represents the total ordering cost. And we move to the next. The blue line here is the annual holding cost, which is half Q times the holding. This is the average quantity you keep on hand for each period, and this is the holding cost for per unit. So this is the total holding cost. And the red line here represents the annual order cost. So if we know the annual demand and we know the quantity you can have for per order, then we times the big K. This is the total annual ordering cost. And the green line here represents the total cost. The total cost equal to the total holding cost plus the total ordering cost. So this is the total cost. And if we take a look with the cost here, we will have an idea. If we take a look with these pictures, when the holding cost equals to the ordering cost, we will have the minimum total cost. So this is what we have. And according to this information, we know this is the interception for this blue line and the red line, right? So the interception means these numbers for the blue line equals to the numbers for the red line, which means the total holding cost equals to the total ordering cost. So this is what we have according to the figures. And if we know the holding cost per unit, and we know the annual demand and the ordering cost for per order, then we will have an idea about how much quantity you should place for an order. So we just move the Q into one side, and we move the other symbols, other notations here in another side. So we just make a little transformation for this formula here. So it equals to QH divided by 2 equals to Q and DK here. And then we move the Q into one side, so we have Q squared times small h equal to 2 2dk, and we will have q squared equal to 2dk divided by h, and then we will have q equal to square root of 2dk divided by h. So this is what we have for the q, and the q here is what we called the optimal quantity. This is the quantity you need to place per order that you will have the minimum total cost. So this is the EOQ, the optimal quantity here we call it the EOQ. So let's take a look with the example here. A bookstore currently orders 300. So currently they have orders 300 Wildcat headphones at a time. So each time they place an order, they place 300 units. And after you identify the opportunity to reduce the inventory cost, you put all the information you connect into these tables here. So you know the demand is 125 per week, and you know the ordering cost is 75 per order, and the holding cost values like 15% of the total units cost here. So the holding cost will equal to 15% times the $40 for the per unit, then it's $6 per unit. So this is the holding cost. We have small h, here is the holding cost. So according to the annual demand, according to the ordering cost per order, and according to the holding cost per unit, we can have an idea about the EOQ. The EOQ after calculation, it's around 404. It means like if you place 404 per order during the whole year, you will have the minimum total cost. So we can compare with these two costs. In the past, if you place 300 per order, the total cost will be 2,525. And if you change the three orders into the 404 into the EOQ, you will have a total cost of 2,418. So you will save money. So this is about the how much quantity the manager, an inventory manager, should place an order. So this is about the EOQ.